Hey, my friends. So we are moving into lesson 2 of grade 5, chapter 9. We're actually going to be doing lessons 2 and 3 today. So we're going to start talking about another way to visually represent our data. And this is a new way. It's not using a line plot anymore. This time we're going to be looking at using coordinate grids or coordinate planes. This is the full coordinate plane that you'll be working with a little bit later in your school, like looking at 5th grade. In 4th grade, we're actually going to only focus on part of this, but I want you to be aware that there's more to this coordinate plane than what we're looking at in 4th grade. So in a coordinate plane, you've got what looks like graph paper, but then you've got these two axes, which is the plural of the word axis, right, that runs through your graph paper. You've got your x-axis and your y-axis. Your x is horizontal and your y is vertical. You'll notice that across these axes, they're numbered, right? So there's a scale that's happening that's numbered equally on the x-axis and the y-axis. So we have 4 quadrants in this section. So this first quadrant right here, this is the quadrant we're going to be looking at more in depth. But then you also have quadrants 2, 3, and 4 around that coordinate plane. So quadrant 1 is a quadrant we're going to be looking at. So I actually have a couple examples that only include that quadrant in it, so that we're not taking up all that extra space with that stuff that we don't need right now. But I wanted you to be aware that there's more to this than what we see here in 4th grade. All right, so let's think about these axes just a little bit more. Axes, again, are the plural of the word axis. You've got your x-axis, which is horizontal. And you've got your y-axis, which is vertical. What is the direction that the x-axis runs? All right, so now we've got those axes. Now I want to point out to you that these axes meet at a certain point right here. This is the point where both of these axes have the number 0 on their scale. This point is called the origin. The origin is located at point 0, 0. All right, that's where the x-axis and the y-axis meet. Now, in the future, your origin might be a different ordered pair, but right now it's always going to be 0, 0. Okay, so you heard me say that word ordered pair, right? What is an ordered pair? Well, an ordered pair is a set of 2 numbers that are listed in a very specific order. The specific order that they go in is always, always, always x and then y. So I've got my x coordinate and then my y coordinate, always. Now that's not just for the origin, that's for any point that I want to identify on this coordinate plane. So let's say that I've got this random point right here, and we'll call it point J, okay? Now, if I want to identify the point, I can identify it with the letter J. That's great. But I can also identify it, and often I'll need to identify it by its ordered pair, which is that specific pair of 2 numbers that uses your x-axis and y-axis to identify the location of that point. In your own words, what is an ordered pair? All right, so now let's actually identify this ordered pair. So the first thing I'm going to do is I'm going to work with my x-axis because my x always has to come first, right? My x coordinate always comes first. So looking along that x-axis, I'm going to count up from the origin, which is at 0, right? From the origin until I get to where my point falls on my x-axis. So if I do that, I see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it looks like that J does fall at the 12 marking on my x-axis. So I know that the first number in my ordered pair is 12 because x always comes first. Then I'm going to do the same thing, but I'm going to count up from my origin for y to see where my J falls on my y-axis. right? So when I do that, I start at 0, I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, and I see that my J falls on that 9 marking on my y-axis. So I know that the y point coordinate for this point is 9. So point J, I could identify with the ordered pair 12, 9. All right, now let's continue. Let's try it one more time. Let's say I've got another point over here, and we'll call it M. Okay, here's my point M. I'm going to do the same thing. I'm going to work from my origin across my x-axis to see where my point lies. And you're probably starting to realize you don't necessarily need to count up all the way. You can just use your eyes to find out where that point M crosses your x-axis. And we see that that's at 4, right? So I know that my x coordinate is 4. Then I'm going to move on to my y coordinate. And I'm going to think, all right, well, up on my y-axis, where does that M cross my y-axis? And it crosses at 9 again. So my y coordinate would be 9. Now my ordered pair for point M is 4, 9. Notice that I put my ordered pairs with parentheses around them and a comma in between. If you don't use that notation, it does not mean the same thing, right? It does not mean an ordered pair. If you just say 4, 9, I don't know what you're talking about. If you say parentheses 4, 9, it looks like you're saying 49 in parentheses. And why? What's the point of that, right? So make sure that you're using this correct notation where you see a parenthesis, a number, comma, another number, parenthesis, right? So what is the proper notation for writing an ordered pair? All right, now our final step for this problem, I want us to think about looking at this grid and finding the distance between these 2 points. We noticed already that M and J both fall on the y-axis at 9, right? So we're going to figure out, okay, how far apart are these two? Let's pretend they're 2 buildings, right? And we wanted to know how far apart they are on a map, like in the towns that you just created. So what we can do then is we can count the number of spaces on the graph that on this coordinate grid that are between the points M and J. And if I do that, I might see 1, 2, 3, 4, 5, 6, 7, 8, right? I see 8 spaces between M and J. So I can say that their distance is 8 units. Now, another thing you could do is you might notice that your y values are the same, and then what we're really doing is subtracting 12 and 4. If I subtract 4 from 12, I will get 8, right? And so we know that the answer then would be 8 units. So there's 2 ways that you could find the difference between 2 points that have the same either x coordinate or y coordinate. What are those 2 different ways that you could use to find the distance between 2 coordinates? All right, so here's our final example of the day. We're going to take a data and we are going to represent it visually on our coordinate grid. So I've got a data set here that I've taken. This is all about V-learning. So here are the days of V-learning, and then here are the number of students in my math class that participated in V-learning that day. So what we're going to do is we are going to graph this information on our coordinate plane. And as you'll notice, I grabbed a bigger piece of paper so that you guys can see a little bit easier. And we'll go ahead and get started. Now, the first thing that I want to do is figure out which axis I'm going to label for the days and which axis I'm going to label for the students. And I kind of like having the days going across, so kind of visualizing my day, my time, going extending from one day to the next day. So over here, I'm going to write time, and then my unit is in days, right? Then my y-axis then will be the number of students that participated, right? So over here I have number of students. Now I can also title my graph, and the title would be Student Participation in V-Learning in Ms. Sharma's math class. information from my y-axis, students, right? And then I took information from my x-axis, right, days of participation, and put that into my title. So student participation in Ms. Sharma's math class during V-learning. All right, so now what I'm going to do is I'm going to take this table that I've got, and I'm going to kind of put it right over here so we can both see it. All right, so I'm going to take this table and I'm going to start plotting my data, right? I'm going to go ahead and use a different color. How about purple? That's my favorite color. I'm going to take this data now and I'm going to start plotting, right? So I know that my x coordinate is going to be that day in times, right? So this is, or time in days, I should say. That's my x coordinate. My y coordinate is my number of students. So all of this data really is ordered pairs. Do you see how I'm taking this and I'm turning it into an ordered pair? So I have 123, 222, 323, and so on, right? So here's what I'm going to do. I'm going to go to day 1, and on day 1, I had 23 students participate, which is all of you. That's amazing. So I'll put a point at 123. The next day, day 2, I had 22 students participate. So I'm going to move over on my x-axis to day 2, and I need to go up to 22 students participating. Same for day 3, 22 students participating. Day 4, back up to 23. So I'm going to day 4, go up to 23. Day 5, I go to my 5 on my x-axis. My y-axis is 19. Not such a great day, but that's okay. 19 and 5. There we go. I'll put a point there. 6 back up to 22. So I go to day 6 up to 22. And so on and so forth. And you're getting the idea, right? So I can plot my data from a T-chart onto a coordinate plane or coordinate grid in order to visually represent that data. What are some benefits that you can see from representing our data in this way rather than using a line plot? What are some of the benefits of using a coordinate plane in order to represent your data? So today you're going to have the option of which problem you'd like to do in order to practice visually representing your data. And I cannot wait to see all of your awesome work. Thanks, guys.